Corporate finance practice problem using OneNote. We're going to be calculating the bond value and comparing and contrasting the bond value if we have different maturity dates. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're going to be in the icon on the left-hand side. We're in the practice problems, then down here in the 1015 bond value different maturity dates tab. Also note, when using OneNote, you may want to look at the immersive reader. Many of our presentations will be mirrored down here in the text files with the same numbers and names related to them. Text files typically having transcripts that can be translated into multiple different languages and either listened to or read in those multiple different languages, thereby making them a good complement to the presentations. Closing this back up, we're going to have our information up top. We will work through that information then down below. So our information says we have the bonds outstanding, par value 1,000. The percent is going to be 17%. These are the items that we can kind of expect to see on the bond or derive from the bond itself, as well as the maturity point from the bond itself. The thing that would not be on the bond would be then the 7% here, yield or market rate, what the market expectations are. Now we're going to be varying then, keeping everything else the same, varying the maturity dates between 35, 12, and 8, and consider what the changes will be with the bond price as we go through these changes in the maturity dates, keeping then everything else the same. So note when we start off here, we have the percent at the 17%, which is far higher than the yield, which is only 7%, the market rate. So if we are on the perspective of us issuing the bond, then we would have basically a big advantage. We'd be saying on the market, no one else is going to find a bond. You're not going to find a bond like our bond out there and that's paying 17%. Other people are only paying 7%. Therefore, we expect to be selling this at a price when we figure the price greater than the 1,000. We expect the price to be greater than the 1,000, selling it at a premium. Then we want to calculate what the price will be. And then the change that we will take into consideration, focus in on, will be the maturity dates to consider the effect on the values from those different maturity dates. So first we'll do this with the maturity date at the 35, the long 35 bond period first. And we got to do the calculations in a similar way as we have in the past. We'll do the calculations a couple different ways with the present values here. If you want to skip forward in the problem to see the kind of the results of them, feel free to do so. So we'll start off with the annuity portion of the 1,000 and the 35 years here. We got the P, this is going to be the annuity function, P times 1 minus 1 plus R to the negative N over R. P then is going to be the 1,000 times the 17%. Then the numerator 1 minus R and 1 plus R, 1 minus 1 plus R. R then is going to be then the market rate, the 7% to the negative N. That's going to be the number of periods, in this case years. 35 is our starting point divided by R, once again the market rate 7%. Putting this then into our table type of format, we will bring the payment out to the outside. That's going to be the 1,000 times the 0.17 or 17%, 170, that being the annuity payments we expect to see happening every year for 35 years, 35 periods. Numerator is 1, we'll bring into the inside column, then the 1 plus the R to the negative N. There's the 1, there's the R, 7%, that being the market rate. Adding those up gives us 107 or 1.07. And then we have the to the negative 35 number of periods, 35 periods. That then gives us our 0.09366294. Let's do that with our calculator over here. Remember that if you do these calculations with a calculator, you need something that's going to be going to the power of that 35 and a negative at that. So I'm going to switch from our normal calculator in the Windows program to the scientific one. We're going to do this in a scientific way. This is a more scientific-y calculation. 1, and then we're going to add plus the 0.07. That gives us 1.07 or 107% to the power of, which is the x to the y, caret up top. That's going to be 35 down below. Going to make that negative, typing it in first, then hitting the little negative thing, making it negative, and enter. That gives us our 0.093669294, and so on. Going to bring my calculator back to the standard calculator, make it a little bit smaller now. Now we're going to finish off the numerator, taking the 1 minus that 0.093666294, and that's going to give us then our 0.906333706. That's the numerator. That's the num. And then the denom is going to be the rate again at 7%. So 7% on the denom. So let's take that amount divided by 0.07, 7%. Make our calculator a little bit bigger so I can see the answer. There's the 12.947 and so on. Taking that amount times the 170 times the 170 gives us the 2.201. That then is the annuity portion of the calculation. We also need to do the present value of 1, the 1,000. We will do that shortly, but before we do, we're going to calculate this one a few different ways. So we will do that with a present value of 1 calculations, and we'll also do it with Excel calculations, which will probably be the way you would want to do it basically in practice if you have the capacity to do so. First, present value of 1, we'll take that 35 period annuity, break it down to 35 present value of 1 calculations, and then analyze each one of those. We won't analyze each one of those, but you could do this easily in Excel here, much less easy to do with a calculator, but conceptually, I think it's worth looking at. So we have 1, we have the payment, which is 170. That's going to happen for 35 time periods. If we present value that, I won't do the calculation now, but just theoretically, it would be 159. You can see the calculation in Excel if you choose to go there and want to figure out the calculation component of it. Then in period 2, we have another 170 because it is an annuity. So 170 per year in this case. Present valuing that back to the current period, that would be 148. That 148 plus the 159 would be the 307. Period 3, same process, 170 annuity. That would present value back 3 periods to 139. That 139 plus the 307 would give us the 446. If we did this all the way down for 35 periods, which would be tedious but easy to do in Excel, we get down to that bottom line number, that 2201, no cents added, no pennies in other words. That matches our 2201 that does have the pennies up top. And that would be another way we can calculate this. We can also then tack on at 35 periods the present value of 1,000, which we will calculate in more detail shortly. That would be worth then 94. 94 plus the 2201 is the 2295. That then would basically be the price. That would be our answer. Notice that that price is much higher than the price on the bond, the face amount of the bond, due to the fact that the rate on the bond is far higher than the market rate, and therefore higher price selling at then a premium. We're going to get to this number again, but first let's recalculate this 2201, the annuity portion, a couple different ways. Once, the most common way or easiest way with Excel would be the function in Excel, which would be the present value of the rate. The rate would be then the market rate, 7%, comma, number of periods, which would be 35 in the first example, comma, the payment, which would be 1,000 times 17, which would be that 170. That then gives us, once again, that 2,201.10. We can also calculate it with the tables, taking that annuity payment for 35 periods, the 170, then looking at the proper table, that being the annuity table, present value of an annuity, percents, 7%, 35 periods. So 7% here, 35 periods, which is the 12.948. So 12.948 times 170, once again, that 2201.16, slightly different, I believe, than the 2201.10. Why? Because the tables are rounded to 4 digits and therefore estimated. Let's do the second half, the second part, present valuing this 1,000 component part of the price for this 35-year maturity. Present value formula equals, present value equals the future value, I'm going to say over 1 plus R, which is the market rate, 7%, to the number of periods, in this case, the 35. So present valuing that, we would expect it to be quite small, given this is quite a long time, 35 periods before this thing expires at this point. It'll grow, you would expect, if you're looking 12 years out or 8 years out. This would be a bigger part of the price you would expect. So we would have the 1,000 here. We're then going to take the 1 plus R to the N. 1 plus R, 7% market rate. Adding those up, 107. Taking that to the number of periods, or the 35 years. 107 caret 35 to the power of, in other words, 35, 10.676581. Then if we take the num divided by the denom, numerator over divided by the denominator, we get the 9366. So that's going to be the present value of that 1,000, bringing it all the way back 35 years, 9366. If we add that to what we got on the annuity, that 2,201.10, we get then to the price again, 2,294.77. That price far higher than the amount on the par value due to the fact that the percent on the bond much higher than the market percent. Also note that that 2,294.77, also something we got to up top when that yellow number, but no pennies, 2,295. There's the 2,295, and there's the 2,294.77. So we've gotten there two different ways. Let's recalculate this portion, the 9366, a couple different ways. Next time, the easy way. This is the easy way, Excel way. This is negative present value. We're going to pick up then the rate, 7%, comma, number of periods. That's going to be 35 periods for the first one, comma, comma, because it's not an annuity. Future value, 1,000. That then, again, gives us 9366. Let's do it with the tables. That's going to be the 1,000, picking up the proper tables this time, this being the present value of 1, not an annuity. 7% at 35, 7 and 35. So we're looking 7%, 35 on the periods. That's going to be down here. That's going to be the 0.0937. So there's the 0.0937 times the 1,000 gives us the 9370, again, matching out to the 9370, or it's a little bit different than the 9366 due to rounding. So that's the first one. Let's see what will change then. Now let's do the same calculation, but now we're not using 35, we're using 12 periods. What's going to be the price of the bond? We still expect it to be sold at a premium due to this factor up here, the 17 on the bond being higher than the market rate, but we don't know the exact price. What's going to be the effect if we change from a 35 period down to 12 periods to the maturity? Let's take a look at it. We're going to do first the present value of the annuity. Formula is going to be P times 1 minus 1 plus R to the negative N over R. P is still 1,000 times 17. 1 minus 1 plus R. R is still going to be the market rate, 7% to the negative N. Here's the change. Here's the changing factor. Now it's 12 as opposed to 35 over R, which is the same, 7%. Let's plug this into then our table down below. We're going to say that we have then the 170 outside. That's going to be the 1,000 times the 17%. Working on the numerator now. 1 minus 1 plus R to the N, or negative N. There's the 1. 1 plus R, 7% market rate. That gives us 107%. Then we take that to the number of periods. Here's the change. Here's the new thing. Here's the difference that's happening. 12 years instead of the 35 that we had last time. So then we're going to take the 107% to the 12 years, power of 12. That gives us 0.44400120. Then we're going to take the 1 minus that 0.44400120. That gives us the 0.5559880. That's the num, or the numerator, in our formula. Then we're going to take that divided by the denom, or the denominator, which is 7%, same as we had last time. Taking that divided by 7. The num divided by the denom gives us 7.9426860. Then we're going to take that 7.9468630 times the 170, giving us the 1,350.26. So that's going to be the present value then of the annuity portion. We then need to present value the 1,000 portion. But before we do, we'll calculate this one a few different ways here. So we're going to calculate it now with I think I got the same thing here. I'm going to scroll down past that one. We're going to do it with a running balance calculation, taking the 12 payments and present valuing each one of them back to present value of one calculation. So let's do that format. We've got payment 1 is still 170, same as last time. We're present valuing it back. That's going to give us the 159. We won't show the calculation. If you want to see it in Excel, you can check it out there. And then we're going to then say the next 170, there's the 170, is now going to be present valued back to the current period, 148. That 148 plus the 159 gives us the 307. Third payment on the annuity, 170, present valuing that back would give us the 139. 139 plus the 307 gives us the 446. We continue on this process, but it doesn't go quite as far because there's only 12 payments. Stopping here at 12 gives us that 1,350, same answer we got up top, but rounded, 1,350.26. 1,350. Then if we tack on the last one, I can say, well, I can do the same thing if I just present value then this 1,000 back to the current period, which we will do shortly later, showing the calculation on how to do that. The 1,000 present value back would be 444. That 444 plus the 1,350 would give us the 1,794. That would be the result. That would be our price that we will calculate again shortly. Note that price is still higher than the par value of the bond due to the fact that the 17% on the bond is higher than the yield rate in the market at the 7%. However, it's not as high as the last calculation we got to. If I scroll back up top to like the last yellow number we got up here, which is we had the 2,293 when we're talking 35 years out, everything else equal. That would make sense given the fact that if it's 35 years out, the annuity, although the payments are smaller as time passes, you get more payments. There's 35 annuity payments that are happening here. Now we're talking only 12 payments out. However, there are some counterbalances. Notice that as you get closer to the end period, this 1,000 will become worth more because that lump sum payment at the end is now closer to the current time period. So, there are some kind of trade-offs. It's a little bit complex to think about, what the impact is going to be when you change some of these factors. But in any case, that's the price, and we changed the number of years. It's going to be less than, but still over the par value. Less than it was at 35, but over the par value. Okay, if we did that calculation, we're back to this one, the 1,350. With Excel, it would look like this. The rate still the same is going to be the 7% market rate, number of periods. That's what changed, 12 this time. And then the payment is the same, 1,000 times 17 or 170. That will then give us once again that 1,350.26, the annuity portion. Let's do it one time with the tables, one more time with the tables for this one before we move on to the last one. This is going to be the 170. That's going to be the 1,000 times the 17 times the amount from the table, this time table amount, making sure we got the proper table. Present value of 1, not an annuity, 7%, 12 periods. 712, and I don't have an annuity table. So the annuity table was not added. I'm blaming the editing team here. It's not my fault. But the amount from the table, had we had one, would be the 7.9472, I believe. And that would give us that 1,350.26 again. I won't do it again. We've done these tables a few times. So we'll move on to the next. Now we'll do the present value of that 1,000 more formally. This would be the second component at that 12 years again. So the present value formula now being present value of 1 would be future value. I'm going to say over 1 plus r to the n. The future value now 1,000, same as it was in the first example, divided by 1 plus r, 7%. The same thing that changes now, that n periods, now 12. So if I go down, we're going to do this calculation. We're going to say the 1,000 outer column, 1 plus r to the n. There's the 1, r, 7% market rate, same as last time. That's going to be the 107. The new thing happens now. That's going to be 12 number of periods this time, as opposed to the 35 that were last time. 107% to the power of 12 gives us the 2.2521916. Then if I take the num divided by the denom, which is 1,000 over that 2.252196, gives us the 444.01 present value of that 1,000. That portion being higher now because we're closer to the end, 12 periods out, as opposed to 35 periods out. Scrolling down, if we add that amount for the present value of 1 to the annuity portion we got to last time, that 1,350.26, we get to that 1,794.27. That then being the price that we saw last time in the yellow area, the 1,794.27, matching the item 1,794 we got up top, but this one not having the pennies on it. So that price higher than the amount for the face of the bond, which was 1,000, which we would expect due to the fact that the market rate on the bond, 17% much higher, the rate on the bond higher than the market rate, which was 7, rate on the bond 17, the market rate 7. However, even though it's greater and we're still having it at a premium due to that fact, this price is less than it was when we had only 35 periods, this time only 12 periods. So now let's do this calculation a couple more times before we get to the last one, that 444.01 present value of 1. We can do that with Excel. Would look like this. We got the present value of the rate, 7%, comma, number of periods, this time the 12, and then the payment amount, the 1,000. We don't have the payment amount this time, but instead of the future value, because it's a present value of 1, that being the 1,000, gives us then again the 444.01. Then we could do it with the tables. We take the 1,000 for the tables. If I have the table this time, I think I do. We're going to then take the 1,000, and we're looking at the table, present value of 1 tables, 7% and 12 periods. So 7, 12. So there's the 7 and there's the 12. That's 0.4440. So there's the 0.4440 times the 1,000 gives us 444.00. That then similar, but 1 penny different than what we got before due to the tables rounding out to the 4 digits. Let's then go on, and we won't go on. We'll stop it here. So I didn't include the 8 periods here, but we get the idea of this. Obviously, you could think about the change that will happen if we have a change in the maturities. Note that no matter what the end period is, if the rates are set up in this format, meaning the rate on the bond is higher than the market rate, then you would expect to be selling at a premium. If we were the ones selling, the price we would expect to be higher than the face amount or par value. But the amount of the price will change, of course, based on the maturity dates. And generally, you would think that if the maturity date is longer, you could have a situation where the price is going to be higher given the fact that the rate, once again, the rate up top for the bond is greater than the market rate.